I'm Mike Rousos, a software engineer on the DevDiv customer engagement team. And today I'm going to be talking about some new tooling that we've been working on with the ASP.NET team to make upgrading from ASP.NET to ASP.NET Core easier. When you think about upgrading from .NET Framework to .NET 6 or .NET 7, the experience that you have really depends a lot on the scenario that's being upgraded. For some workflows, like Windows desktop applications, console apps, class libraries, the upgrade experience is pretty smooth as long as you're not depending on a couple of areas where we've had larger surface area changes. Even when you think about server-side WCF scenarios, now that Core WCF version 1.0 has been released as a .NET Foundation project, upgrading WCF scenarios to .NET 6 and .NET 7 usually isn't a whole lot of work. But when you look at upgrading web scenarios, those can still be a bit more challenging because ASP.NET and ASP.NET Core have fundamental differences in the way the apps start up, serve requests, and their surface areas. We have tooling available that helps with .NET upgrade. We have the .NET Portability Analyzer that you can see at the top of this slide that gives you insight into which APIs you're using from .NET so you can understand whether you're likely to need a lot of changes going to .NET 6 or .NET 7, or if things will come over mostly as they are. We also have the Upgrade Assistant, which allows you to interactively upgrade a solution as it guides you through the different changes needed in the project file, the config files, and the source files. But even when using these tools, upgrading ASP.NET apps can still be a challenge because after Upgrade Assistant has run, there's usually a lot of manual changes still required because of the differences between ASP.NET and ASP.NET Core. So today I want to focus on some new tooling that can help with two specific scenarios within that. The first one I want to look at is the idea of a large ASP.NET MVC or Web API solution. This can be a challenging upgrade project because once you've begun upgrading an app to ASP.NET Core, it has to be completely upgraded before it's going to work. There's no opportunity to do bits and pieces. Once you've changed the project file to target ASP.NET Core, that project isn't going to build until there's no more references to System.Web or anything else ASP.NET related. This isn't a problem for small solutions because you run Upgrade Assistant, you spend a day or two changing your APIs, you change your startup code paths, and you're off and running. But for a really large MVC or Web API solution, there might be weeks of manual fix-up to upgrade to ASP.NET Core, and during that time, you can't even build your project, you can't deploy it, and you don't have a functioning app. So we have some tooling now that we hope is going to help with that. The second scenario we're going to be talking about is that of class libraries with web dependencies. For most class libraries, upgrading is easy because you target .NET Standard, and now you can be used by either .NET Framework or .NET 6, .NET 7 callers. But for web-specific scenarios, class libraries are trickier because they have to choose whether to use the System.Web-based ASP.NET APIs or whether they should change to use the new Microsoft ASP.NET Core, ASP.NET Core APIs. And whichever you choose, that library is going to need to target either .NET Framework or .NET 6, and it won't be usable from the other type of application. So if this library has some callers that are still running as ASP.NET apps and other callers that have already upgraded to ASP.NET Core, you end up having to duplicate this code so that you have one version for one set of callers and one version for another set. And today we're going to be talking about some preview tooling that can help with that scenario as well. So the first thing I want to show off is a new Visual Studio extension that the ASP.NET team has created that allows you to have a workflow inside of Visual Studio for migrating an ASP.NET app, which adds a new ASP.NET Core project into your solution alongside the original ASP.NET app without changing that original app. Now, when this new project is added, it's set up in such a way that launching or deploying the original ASP.NET app will also take the new ASP.NET Core app and put it in a separate virtual directory alongside the original app, so that when requests come in, the new ASP.NET Core app has an opportunity to serve those requests first. And if it's not able to handle them, then transparently to the end user, the original ASP.NET app will handle the requests. What this means is that you can begin taking specific endpoints out of your ASP.NET application, controllers, action methods, moving them over into this brand new ASP.NET Core application a little bit at a time. And to the end user, nothing will look different. But as time goes on, you'll have been able to incrementally move more and more of your application to ASP.NET Core until eventually only the ASP.NET Core app is serving requests, and you can remove the original ASP.NET project and the proxy between them. In this way, you're able to more gradually move from ASP.NET to ASP.NET Core. Under the covers, this is using our YARP technology. That's yet another reverse proxy. Now, this tool's been around for about half a year, so some folks probably already have used it, but I just want to call it out in case you're not familiar with it as a useful library that you may want to look at for its own merits, not just in upgrade scenarios. What we found internally at Microsoft was that a lot of teams were creating reverse proxies in ASP.NET Core scenarios or asking for guidance on how to do that. Rather than let teams keep recreating these tools over and over again, the ASP.NET team created YARP as a reverse proxy library designed specifically for creating fast and customizable reverse proxy apps on ASP.NET Core. It was released as a 1.0 back in November and already has more than 400,000 downloads. And work is currently going on to add some really cool new features for version 1.1. We're adding HTTP 3 support, as well as a whole host of perf improvements, bug fixes, and just general quality of life improvements. So if you have a need for reverse proxy stuff, I would definitely encourage you to go check out YARP, give feedback in the GitHub repo on some of the new 1.1 features, and try that out. In the context of upgrade, though, this is what's happening under the covers that allows requests to be transparently routed from that front ASP.NET Core application to the existing ASP.NET one in cases where an endpoint hasn't yet been migrated. Okay, now what about the other scenario where you've got a library with a bunch of web dependencies, but you need to be able to use this in modern solutions while also using it with some callers that haven't yet upgraded? For that, we've been building a package of System.Web Adapters that targets .NET Standard 2.0 so that you can take libraries with web dependencies, use these web adapters, and you'll still be able to access common System.Web APIs while targeting .NET Standard 2.0. So you have a single library that's then usable from either ASP.NET or ASP.NET Core callers. In the case where ASP.NET uses this library, the adapter will type forward the necessary System.Web APIs onto the actual System.Web types. In the case of ASP.NET Core callers, the adapters will translate this API surface area into ASP.NET Core equivalents. So you can end up with something like this code you see in the slide, where you have ASP.NET System.Web style API usage inside of a library, but it's able to target .NET Standard 2.0 and be used from a variety of callers without having to make any source changes in the library itself. So far, the web adapters support key parts of HTTP context, HTTP request, session APIs, cookie APIs, caching, and a couple of other high priority APIs. This is still in preview, and so would love to get feedback on which parts of System.Web are most important for you to be able to take your libraries and use them on ASP.NET Core. Along with those System.Web adapters, we're also working on some session sharing technology that will allow apps that use the web adapters to access session through APIs that have the same shape as System.Web session APIs, but are set up in such a way that if you're in that migration scenario where you have both an ASP.NET Core app and an ASP.NET app, both serving different parts of your application behind the scenes, you can have them share session state. So if one of your endpoints is migrated to ASP.NET Core and the user hits that endpoint as part of serving the request, some session items are updated. Later on, if the user makes another request that is served by the ASP.NET app, because maybe that endpoint hasn't been migrated yet, those same session items will be available. We're modeling this after the ASP.NET System.Web session API, so we've included session locking the way that ASP.NET does that today. and you're able to store any JSON serializable objects. Under the covers, what's really happening is that the new ASP.NET Core endpoints are proxying the requests to load or commit session state back to that ASP.NET app, which means that if your ASP.NET app has any sort of custom session store provider, or if you're persisting session state out of proc or in a database, that all continues to work automatically. So I'm going to dive into some demos, but I just want to make sure that I get this link out here early on. If you're interested in learning more, go out to aka.ms/ASP.NET Core Migration. All of the stuff I'm showing today is currently available in preview. Would love for you to try it out. Give us feedback on GitHub as far as what's working, what's not working, what you'd love to see us focus on next. Or if there's something that you wish worked a little bit differently, open a pull request and would love to take community contributions. So let's go ahead and jump into a demo of how this all works end to end. Here in Visual Studio, I've loaded the eShop sample, which is a small ASP.NET MVC application that implements an e-commerce solution. It's running on .NET Framework 4.7.2 and just has a small collection of controllers, views, and a few web API endpoints. It does depend, for demo purposes, on a .NET Framework class library, which has some helper APIs that end up using System.Web stuff under the covers here. So if I want to start migrating this to ASP.NET Core, an easy way to start is to use the extension that we were talking about inside of Visual Studio that adds this new Migrate Project option when I right-click on my project in the Solution Explorer. By clicking on that, I get this UI that asks how I want to migrate. So I'll click Start a New Migration, and I'm asked whether there's already an ASP.NET Core project that I want to couple to this ASP.NET one for purposes of migration, or if I need to create a new project. This is the first time I'm doing this, so I'm going to create a new project. A project name is recommended, which seems fine. And I choose whether I want to use a web API or MVC template. This is primarily an MVC app, so I'll choose MVC. And then I click Finish. So now at this point, the tooling is going to scaffold a new ASP.NET Core MVC project, which is basically the same as what you would get if you ran .NET New, with just a couple small changes that we'll look at to set it up to proxy things back to that original ASP.NET request. So you can see here that we have a new project, eShop Legacy MVC Core, and its program.cs is basically a new project template, except that we've added reverse proxy services, and we have registered reverse proxy endpoints. When we register these services, we're loading the proxy configuration from our app configuration, and in appsettings.json, you can see that it added for us some proxy configuration, which right now is empty. But this extension is set up so that when we launch our original ASP.NET app, it will also launch this new ASP.NET Core one with it, and it will fill in the information we need as far as the address to proxy to and things like that, so that it all automatically works. And that's going to happen whether you're launching via F5 to debug inside of IIS Express, or whether you're deploying the application. We also have some options inside of our debugging menus to choose whether we want to debug the .NET Framework half of the application or the .NET Core half of the application. And you can go back and forth between those as you need to. So let's go ahead and test this out. I'm going to hit F5 here to launch the application. And remember, this is going to launch both apps in different virtual directories simultaneously, proxying between as needed. Requests will first go to that ASP.NET Core app. And so when we launch, because our program.cs lists home as the default controller, we're going to be taken out to a home controller, which is implemented in the ASP.NET Core app. So what we see here that just started up is that we are seeing the ASP.NET Core homepage. Now, if we look in here at our solution, though, you can see that that's the only controller we have in the ASP.NET Core app. In my original application, we have a catalog controller, which is actually the default controller, so I should switch that to be our default. But that's not implemented yet in ASP.NET Core. So if I give a /catalog endpoint, now the ASP.NET Core app isn't able to serve this, so we're going to proxy to the ASP.NET app instead. You can see some stuff's loading here. We lazily load the ASP.NET app, or the assemblies for it, the first time that those endpoints are hit. So the very first time that you hit an endpoint that isn't served by the core application, you'll notice there's a small delay while everything starts up. That's only for the first call to the ASP.NET app, though. So once you start hitting those endpoints after that initial call, everything should be very fast and not noticeable. Inside of the ASP.NET app, nothing has changed except that there are a couple properties that were added to this project file so that the VS extension knows which application pairs with this application for migration purposes. So we'll go ahead and give this a minute just to finish launching here. Okay, and it looks like it's done. So you can see that before we were at our home endpoint, but then when we navigated to catalog, this is being served from the original ASP.NET app, but to the end user, it doesn't look like anything's different. And they can go and use this application the same as they would before without realizing that for some endpoints, like home, index, this is actually being served by a different ASP.NET Core application. Okay, so let's go ahead and actually move an endpoint over and show what that looks like in practice. So inside of our catalog controller, there's a couple different endpoints. Let's grab one of these. How about details? A minute ago, I went to the details page to show information about one of the products in our eShop catalog. I'm going to comment details out here in my ASP.NET app, and I'm putting a comment, migrated to ASP.NET Core. Then in my ASP.NET Core application, I'm going to add a new controller, and we're going to call it catalog controller. Let's give the template here a minute to catch up. Catalog controller. And I'm going to give it an endpoint of details. Okay, so now we've got our details endpoint in the new ASP.NET Core app. We have to make a few small code changes here for API differences between ASP.NET and ASP.NET Core controllers. Down the road, this may be something that the System.Web Adapters could help make unnecessary, but these sorts of controller level helpers hasn't been a high priority. So right now you still have to update those by hand. We also need to fix a few other things here. Excuse me, because there are pieces of our application that the controller depends on that also need to be migrated over. Now, if this were a scenario that we expected to be running in a hybrid state like this for a very long time, it might make sense to pull some of these dependencies, like our catalog service, out into a separate library so that the code can be shared between the ASP.NET and ASP.NET Core apps. In this case, I don't expect the ASP.NET app to stick around a lot longer, so I'm just going to copy the code over, and that's going to be fine. So some things that my controllers are going to depend on are we're going to need our models, our view models, and our services folders. I'm going to copy those, and I'm going to paste them into my ASP.NET Core application. So now I can go ahead and do like a control dot here, add some using statements, and all of a sudden I have access to my services because those parts of my application were just business logic, data access, which all work fine on .NET 6. They don't require any changes. So I'm able to move those over very easily, and it's just the ASP.NET portions of the application that require some more changes. I also have a logger here. Let's look at our old controller to see what this is. So we're using some log4net APIs here. Also, I see that I'm getting my catalog service via dependency injection. I'm going to copy these, go back to my new controller. I'm going to paste them in. Now, because we're using log4net, in my new project, I'm going to go manage NuGet packages, and I'm going to search for the log4net package. Log4net is supported on .NET 6, so it's no problem to just select the log4net package, install it, and now that same logging code is going to work in the new application. Similarly, I know that the catalog service that I moved over is using Entity Framework for its ORM under the covers. So we're going to need Entity Framework installed as well. Now, I don't need to move to Entity Framework Core yet, even though that's where a lot of our new innovation's going, because Entity Framework 6 works on .NET Core and .NET 6 and above in recent versions. So by installing Entity Framework version 6.4, I'm able to take my existing data access code, use it directly on .NET 6, and that's an easy way to get things migrated over. Okay, so I've added a couple NuGet packages. I've added my my endpoint here. Let's go ahead and add some using statements for log4net. Oh, and you know what? I pasted this outside of the class. That's not going to work. We need to put this inside our class here. Okay. So at this point, things are almost done. I need to add a couple more using statements. I do need to get a view for this, of course. So I'm going to go into my ASP.NET Apps view folder, and I'm going to copy the details view. And then I'm going to come down into the views folder for my new ASP.NET Core application, add a new folder. I'm going to call that folder catalog. I'm going to paste the views or the details view. Okay, so I've got a view now for the details endpoint. Finally, we have this helper method that was part of the details action method. So let's go over to our controller and see what this helper method is. Here it is down at the bottom. Let's go ahead and copy this helper method over into our new catalog controller as well. Now this one's a little bit tricky because you'll see we're using route URL to dynamically generate the route where we can retrieve the picture of a particular item so that we can populate that URL in the item's model in this controller action method. The problem is that even though route URL exists in ASP.NET Core, the controller that we're getting a route for hasn't been migrated yet. So we can't use route URL to go get the route for the pick controller because the pick controller doesn't live in this app yet. Eventually, once I've moved the pick controller over, we could continue to use this approach. For the time being, though, because I know what that URL should look like, I'm just going to hard code that in. Let's see, we're just going to select all of this, and I'm going to I'm going to paste in a hard-coded URL instead because I know that items/the ID/pick is the URL for that pick controller in the other ASP.NET app. So this is going to populate the right URL for going and retrieving the pick. Okay, so we now have enough of our controller here that we should be able to build this and have our details endpoint. Let's go ahead and try it out. There may still be some issues in the things we copied over, the models, the services, all that sort of stuff, but I think we're getting close. Okay, so let's take a look at our output. Yeah, sure enough, I do see a build error here in catalog DB initializer. So if we take a look, this is an example of where there are just some small differences. Let's see, here we go. You can see there's just a handful of places here where this class was using hosting environment to get the physical path of where this app is coming from so that we could load some spreadsheets with seeding data. This is pretty easy to fix. We just pull out these couple of calls and put in .NET 6 equivalents for getting the current location. But in this case, because this is just seeding data, I know it's not actually used by our controller. So for keeping this simple, I'm just going to comment this whole class out. We don't actually need it yet in our ASP.NET Core app. Okay, so at this point, everything should build. We do need to register some things in DI, though, because remember, we're getting our catalog service out of our dependency injection container. So I'm going to hop over into program.cs, and I'm going to drop in, let's see, let's go over here, drop in a couple more services we want to register. We want to register our catalog service. We want to register the DB context that we're using. And also this DB context is interesting. Let's take a look at how it's getting its connection string because we never specified a connection string. Okay, it was just getting it sort of automatically out of web config, which isn't going to work. But what we can do instead here is we can load the connection string explicitly from configuration by saying that we need to get a configuration object when creating the catalog DB context. And the connection string for that DB context is going to come out of configuration. So we'll move over into our app settings.json, and we're going to add that connection string so that we can retrieve it for the DB context. Okay, at this point, everything should work. I'll also, in program.cs, because we know that catalog is expected to be the default controller for this application, I'll update my new project template to specify that instead of home. So at this point now, I should be able to launch this, and we've taken just a single action method from our ASP.NET application. We've migrated over to ASP.NET Core along with the services and the things that it depends on, but we haven't had to make any changes to the ASP.NET app itself beyond just commenting out the things we don't need. And the entire application from the user's point of view is going to continue to work. We're going to have to wait just a minute for this to load because, again, we're going to be hitting the catalog controller, which means we're going to have to load all of the assemblies for the ASP.NET app as well as the core one. So we'll give this just a moment to load. But once this is done, then we'll be able to test this working end to end. I'll come back over here. You will notice when this loads, though, that there's going to be some small differences in the details page from some of the other pages. And the reason for that is that we haven't moved over our layout yet. Both of these applications have a layout.cshtml in their shared views, but in the case of the ASP.NET Core one, we just have our default layout that came with the new project template. In the case of our original application, there is a layout in here that puts some eShop branding. It gives a little footer with some diagnostic information about when our session started and what the user agent is. And so we haven't moved this part over yet, so the pages will look a little bit different. To get them exactly the same, the next thing we're going to do is we're going to jump in here and we're going to take our original layout and we're going to copy that over to our ASP.NET Core app as well, so that then the endpoints really are identical and it'll be difficult for users to tell which one they're looking at. Okay, so again, we launched our ASP.NET application, but both started up. And because the catalog index action isn't in our ASP.NET Core's app yet, we went ahead and served the base catalog page from the ASP.NET app. And you can see that by the fact that we have this layout in use. If I click on details, though, this isn't going to be served by ASP.NET because remember, it doesn't even have that endpoint anymore. Instead, this endpoint gets served by our ASP.NET Core application, and we're going to take a look at what that looks like here. So again, we started with our catalog. I click on details, and just like that, I'm viewing the details page, but this is actually the endpoint that we migrated to ASP.NET Core. You can see the layout is a little bit different. We don't have our fancy footer. It just says copyright eShop Legacy MVC Core. And we've got these links up at the top that take us back to the ASP.NET Core portions of the site. But the content was served properly, even though we linked to it from our ASP.NET app, which I think is really cool. So next, what we need to do is we need to take this layout and we need to move this over. But this gets a little bit more complicated because look at this. That footer that shows the machine name of the server that served the page and the session start time, that information is coming out of session. So we need to be able to get session information that was set in the ASP.NET app for serving a page from ASP.NET Core. So we're going to use some of that session sharing I talked about. Also, even though getting the user agent is a pretty trivial thing to do, I'm getting that from a helper library here, just so that we can demonstrate the way that we can take these libraries and make them work on ASP.NET Core also. Because if I go to definition here, of course, this is my utilities library that's targeting .NET Framework and has a System.Web dependency. Now, I don't want this demo to go super long, so I'm going to switch over to a version of this app where I've already made those changes. I'm going to walk you through what it looks like. So here's that same exact application with just another 10 or 15 minutes of work. And what we've changed is that in addition to adding our usual services, I've added a reference to our System.Web Adapters, and I'm now registering System.Web Adapter services, and I'm calling a method to configure a remote session. And the only things we need to set up for that are we need to provide the connection string of where to get the remote session information from. And we're just reusing that address that's getting auto-configured by the migration tooling. So we're going to reuse that proxy address. I specify an API key for security to make sure that this is an authenticated caller, an authorized app that is allowed to go and get session state information. And then we do require that any items that you load from session state are registered. You register the key names along with the type of the session item. And we do this so that we can deserialize session state in a strongly typed way, which is more secure than the way that it worked in ASP.NET previously. So I've added these changes here. I've also added one piece of middleware for my System.Web Adapters. And now this is going to work. Of course, I need to be able to update my session or my layout. Let me show you the layout here. Here's my layout page. You'll see it looks very similar to the one we were looking at before from the ASP.NET Core app. or from the ASP.NET app, I should say, except that I'm now specifying System.Web HTTP context to differentiate it from the ASP.NET Core HTTP context, since I need to use the System.Web session APIs for retrieving machine name, session start time. And we have this dependency on this web helper, so I had to update my helper library to target .NET Standard, but because I added a reference here to our System.Web Adapters package, we didn't have to change this code at all. This is the exact same code that we had before, but now this library can be referenced from both the ASP.NET app and the ASP.NET Core app. So let's go ahead and launch this one and see what it looks like now. Give this a minute to start up. Also, while this starts, I'll point out I did add 2 extra controllers just to demo some cool stuff about the session sharing. You'll notice in my ASP.NET Core app here, I have a new controller called ASP.NET Core Session Controller. This controller just loads a session item that has a complex type. It has both an integer and a string property on it. And it shows a view that will display the information for that session item and allow us to edit it. And when we post back with that page, the post request that we make submitting the form is going to update that session item in session state. I then have the same exact controller in my ASP.NET app, except that it's served on a slightly different endpoint. So I can get that behavior either from my ASP.NET app or my ASP.NET Core app. And either way, I'll show you what this looks like. We're going to load this session item, and then we're going to display it to the user. And then when they post by submitting the form, we'll update that session item, and we'll get to see how the updates that are made in one half of our application are reflected in the other one. Okay, so we're just waiting now for the app to finish starting up. Again, when you're debugging, it takes a minute to start up, but it should be ready momentarily here, and we'll get to see this working end to end. I'll go ahead and bring my browser window open so we're ready. So at this point, we're just kind of waiting for everything to finish starting up, and we'll get to see it all working. Oh, I will point out, actually, while we wait, that there was a small change needed in the ASP.NET app to enable this, which is because we're connecting to it to get or store session state, I had to register that same session API key here so that we know that the connections that are being made are secure and authorized. We also register the same session names so that when the ASP.NET Core app retrieves information for these session objects, we're able to serialize them in a strongly typed and secure way. Okay, so at this point now, we should be about ready to show this off. Just waiting for the last few libraries to load. Okay, so this loaded now, and so you can see here's our same catalog landing page that we had before, but now if we click on details to see the details of one of these items in our eShop catalog, we're going to get that same branding, and hopefully we're going to have the same footer that's showing information that came out of session state, as well as that user agent that we got from our helper library. This is my first time hitting details, so it's a bit sluggish, but in the future this is going to be fast. Okay, here's the details on that item I clicked on, and you can see down here that we are sure enough getting the machine name, when the session started, out of our session state that's shared between the 2 apps. We also have this user agent that was retrieved from a helper library using our System.Web Adapters. And the user now is using the eShop site, and to them, it feels exactly like it did before we made any changes to it. But when they're clicking on the details page, that piece of the application alone has now been migrated to ASP.NET Core and is all sort of working transparently. Finally, let's go ahead and test out the endpoints I was telling you about I added to demonstrate the session sharing. So if I go to the ASP.NET Core session endpoint, this shows the values for the integer and string properties on that demo item. So let's go ahead and say that we would like this integer to be 123, the string to be ABC. Update this. So now, because I've updated that, when I come back to this page in the future, it's going to show me those values. But if I go to ASP.NET session without core in there, this is going to be the endpoint that's running on the ASP.NET app. And you can see it shows me the same values for that session state. I can change them if I want to, update session state. And now, when I go back to my ASP.NET Core endpoint, we see the updated values. So again, These tools are meant to make it easier to take existing ASP.NET apps, incrementally move them over to ASP.NET Core, reuse some shared libraries along the way, and just generally get on the latest versions running on .NET 6, running on .NET 7 as easily as possible. I'm going to toss back up this one slide that we had in case anyone missed it the first time around. But if you want to learn more, you can go out to aka.ms/ASP.NET Core Migration to learn all the latest on this migration tooling effort, to get access to the preview bits, and to give us feedback. Thanks for watching.